Hello guys, welcome back to my channel. So today I'm gonna introduce you to a new chapter, circles. So this chapter is all about the formula, the surface area and all. So let us start. Before starting, if you haven't subscribed my channel, do subscribe it now so that you can get all the latest updates on time whenever I post a new video. So starting with the notes or the introductory part, you can say. So very firstly, we have the definition. So what is the definition of circle? Circle is nothing but just a collection of all points in a plane which are at a fixed distance from a fixed point in the plane. It is called a circle. The radius is a fixed point which is called the center of the circle, and the fixed distance is called the radius of a circle. How can I explain this? Suppose if this is a fixed point and I draw it to any point of the circle, then it is the radius and this fixed point is called the center. Then interior plus exterior and circular region inside. Now this all inside the circle is the interior region, all outside the circle is the exterior region, and this boundary or this periphery is known as circular region. So the circle and its interior makes up the circular region. All this radius, center, chord, diameter, everything lies inside the circle or in the interior region of the circle. Then diameter of the circle and the chord. Now here XY and PQ is the chord. Where are they? XY and PQ. Now you see that PQ is the longest chord because it is the diameter. So we can say that diameter is the longest chord of a circle. It simply means that PQ is a chord. The chord which passes through center is called diameter, wherein diameter is 2 times the radius or diameter is half the radius. So the fact is that the diameter is the longest chord and all these diameters have the same length, which is equal to 2 times radius. Or you can also say that if this is a radius OA and there is another radius, suppose OB here, then OA and OB will be of same length because we are starting it from a fixed point, and because the periphery remains the same, therefore the radius and diameters always remain the same in length. So now after this comes the next topic, that is arc. Suppose if I take this, okay, before that segments. If this is xy is a chord and this is particular xpy, this is a minor segment and this is a major segment. And arc xpy and arc xqy. Now how will I explain it in a defined manner? In a defined way, we can say that any line segment PQ passing through the center of a circle, having the two endpoints P and Q on a circle, is called a diameter. I've already explained this. So major and minor arc, an arc whose length is less than the semicircular arc is called the minor arc, and if greater than semicircular arc is called the major arc. Suppose here, if you see here in the circle, here we have AC and suppose this point is O, it is not labeled here. Suppose this point is O, so OA and OB are the radius, and here ACB is the arc. So when we say that ACB is a minor arc because it is covering less than the semicircular region. What is the semicircular region? This is a semicircular region wherein the diameter is passing straight through the this radius, the fixed point. That is when two arcs are equal, that is each semicircle, then both segments and sectors become the same and is known as semicircular region as shown in the joining figure. So here it is a semicircular region. Coming back to the figure, so we can see that it is less than the semicircular region, so it is simply the minor arc, and because ADB is more than the semicircular region, therefore it is the major arc. Then in the definition we came to know about segments and sectors as well. So what is segment? Segment is the region enclosed by an arc and its corresponding chord is called a segment of the circle. The segment containing the minor arc is called the minor segment, and segment containing the major arc is called the major segment of the circle. In order to explain it, we will take this figure. Suppose if AB is a chord and this is a arc, this is a minor arc. So there is a chord and a minor arc, so it is minor segment, and there is major arc and this is again a chord, then it is major segment, and the center is O. Then the minor and major segments of a circle are called alternate segments of the circle. This is the point that you need to remember. Then sector of a circle, so the region enclosed by an arc of a circle and its two bounding radii is called a sector of the circle. So see, this AOB, the inside shaded region, is a sector, while AB is the arc and if we just draw it like this, we extend AO to here to C point, then ABC will be a semicircular region as shown here in the figure. Okay, then moving on to the concentric circles. So suppose considering these two circles, so these two circles have the same radius, sorry, have the same center. This circle, the insider circle has also this O center, and the outsider circle has also the center O. So when the two circles have the same center and different radii, then they are called concentric circles. This is a point that you need to remember. You can just read it, no need to explain. Degree measure of an arc. Let AB be an arc. This is adjoining figure. Let AB be an arc of a circle with center O. If angle AOB is equal to 0 degree, then the degree measure of AB arc will also be equal to 0 degree. So we write M stands for measure. Measure of AB arc is equal to 0 degree. That is angle AOB is equal to 0 degree. Just see here angle AOB. So it corresponds to ABR. If we say this angle reflects angle AOB, then it corresponds to the major arc AB. Okay, this is how we measure it. Okay, semicircular region we already know. For a circle we can divide it into 4 quadrants, the 4 sectors, or we can say the congruent arcs are like the two arcs AB and CD, like this, AB and CD. These are the two congruent arcs wherein they have the same degree measures. That is AB arc is congruent to CD arc. It simply means that measure of AB arc simply means AOB angle, and CD arc, that is COD angle, is both are equal. So this angle AOB will also be equal to angle COD. This is one of the theorem that we will study soon. Then talking about congruent circles. So we can say that the circles are congruent only when they have R is equal to S. Cyclic quadrilateral is a quadrilateral. ABCD is said to be cyclic if all its vertices lie on a circle. Points lying on a circle are said to be concyclic. Like here, ABCD is a cyclic quadrilateral which is inside in a circle. In the adjoining figure, ABCD is a cyclic quadrilateral and hence the points ABCD are concyclic. Here you can read these pointers if you wish to. So this was the introduction part of circles, wherein we have covered the key topics inside the chapter. In the next upcoming part of the video, we will be soon covering the exercise 10.1. Ask it out related to it in the comment box. Do subscribe my channel. New video coming soon. Bye bye. Love you all.